Parallel processing challenges. You everybody know what is your parallel processing. Yes, executing a multiple applications simultaneously. For example, let you take your computer itself, computer or laptop. You take your computer or laptop, even though your mobile phone, okay, even though your mobile phone, one of the example for parallel processing. For example, in your laptop, you people are downloading your I'm just going to do three particular tasks by using my laptop or my mobile or through your computer. So first task I will call as process. So one thing I'm going, first task I'm going to download my videos. Okay, just downloading my videos. And the same time, what I'm doing simultaneously, I'm just hearing some audio song. I'm just hearing some audios, or let it be any songs. Okay, and third things, and the same time simultaneously, I'm working on my PowerPoint. I'm working on my PowerPoint. So this each thing will called as task or will called as process. So let I'm taking my computer, so computer or laptop or mobile. One thing I'm just downloading some video file. As second, I'm just hearing some music audio file. At the same time, just working in your PowerPoint, that is in your PPT. So all this you are doing at the simultaneously at the same time. So while doing this, all these three process or task at the same time, will you get your same speed? Will you get your same speed for all these three process? No, you will not get the speed for all the three process. Your speed will not be in same. Okay, the speed will be get reduces. That is, your speed will not be in the same speed because we have only one processor. Each computer have only one processor. So this particular, to complete this particular task or processor, it need a speed. That speed will not be distributed equally for all your three process or a task. Okay, so because what is the reason for that is because each computer have only one processor. So if you use three processor for a single system, if you are using three processor, what happen? The cost will be very more, and it will be very quite complicated to control all the parameter, all those things. So by using my uniprocessor, I'm going to use this parallel processing challenges. So our first challenges will be a speed. So when you are utilizing, so when your people are going with doing a multiple process task, all the particular task will not be entered in the same speed. Okay, so this will be my main challenges while I have to focus on your parallel processing. That is your speed. You can't able to get the speed of all the three process same. So once the video will be downloaded at first and the audio will be playing on, and your speed of your PPT will be less. So if you are using more number of application, what happen? Your systems will be get, the speed will be get reduced. The same thing in your mobile. If you are opening multiple types of application, what happens? There will be a hack, or there will be a stuck in your mobile while using. That is due to the parameter of your speed. So the speed will be the main task for us while you are considering your parallel processing. So your parallel processing will increase the performance of the processor. So we know this parallel processing, one of the 8 ideas of computer architecture, which is used to improve your performance of the processor. To improve this performance of the processor, now you have to reduce your execution time of the particular task or process. So this parallelism will be difficult only in your software side, not in your hardware side. So you people will remember processor now you people will think in mind of hardware. No, this parallelism while you people are implementing, it will be very difficult only in a software side, not in a hardware side. So how it is difficult in the software side now? Because the main thing is here will be application program. So I told you it is not in a hardware, it is only in a soft side. So software side now, what makes it is difficult? Your parallelism, your application program. So the main important factor will be application program. So you have to rewrite the program to complete this particular multifunctional task. Okay, so you have to rewrite your application program to execute this multifunctional task or a process to execute by using the multiprocessor. So this is the main task which is done by the software side. So for example, I have taken a reporter. Okay, so I have taken 8 reporter. So reporter 1 to 8. 8 reporter going to write a report for me. 8 reporter going to write a different 8 set of report. They're going to write a report based on one issues. So while writing this 8 reporter will write in different manner. Yes or not? All the 8 reporter will not have the similar character or similar information. They're thinking of a way of thinking. All will be different for all your 8 reporter. So here your reporter, let it be a processor. Your reporter, let it be a process. That is your task. And a reporter need to write a report. I told you it need of paper. They need of paper. No, that paper will called as memory here. So I just consider here 8 reporter. The 8 reporter going to write a report. So to control this 8 reporter, there should be a one person. That person will be my computer. Okay, ba? So to control all this 8 reporter, all your 8 tasks. Okay, let it be a task or process. So to control all these things, what you have to your computer, one person should be there. That person will let it be your computer. So this reporter need to write a report. Na need of paper. Na it need of memory. It need of my memory. And this reporter need to sit, so they need of chair. No, that chair will called as process. That chair will called as process or processor. Okay, so this you have to just connect this reporter along with your computer, then you can able to find out what will be the parallel processing challenges. It will be very easy to understood those things. So what happened, so now your reporter, what this main thing is, now your reporter is writing the report, way of thinking will be different between the reporters. So now all the 8 reporter will not complete this task at the same time. Okay, so all your 8 reporters will not complete the task at the same time. For example, the reporter 2 can complete his work at first, and then reporter 4, then at 7. So it is not, they are not doing this work simultaneously, not finishing at the same time. So this is the main challenges we have to focus while you are doing your parallel processing. So what you people will think, all these 8 reporter need to complete his work at the same time. Now you people will think in your mind to have a different processor. So if you have a 8 processor, it will make our efficient will be very less. Okay, the system efficient will be very less, and the cost of the processor also will be very. So if your computer have of 8 processor, the cost of that particular system will be very more expensive, because each processor, so that a computer with single processor, it cost of rupees 5,000. Okay, the processor, the computer which have a single processor, the processor cost is for 5,000. If you have 8 processor, 8 into 5,000, it will be more. So you can't able to provide the multi-processor inside a system. So to overcome, what is the overcome or what will be the solution for this particular factor is, the solution for this will be your shared memory. So all the 8 reporters should complete your work at the same time. So to complete that, you should not use a multiprocessor. By using my uniprocessor itself, by using my single processor itself, I need to complete this parallel processing by utilizing the concept which is called as shared memory. So to overcome these challenges, what is the important factor we came out, we'll call as shared memory. So in the shared memory, what we are going to do is, the concept of this shared memory is, let for example take a 3 computer, have a 3 computer. All these 3 computer will be connected with my same memory. That is, all your 3 computer can able to access your same memory. Okay, so you have a 3 computer, 3 processor, and all this process is connected with only by your single memory, not a different memory. All this is going to have a same memory. For example, a shared memory, a good example will be a Facebook and your Google. Okay, I told you a shared memory, your 3 computer will be going to access your a single same memory only. A good example for the shared memory will be a Facebook and Google. So what happened? Let you take a Google. Okay, let you take a Google. Okay, if you're going and searching the certain things, now you'll get many information, because the server of that Google will be very large. So at per second, many number of users can be access that Google information. Okay, there is no limit, or the user, okay, the limit of the user will be very large, because the server of the Google will be very large. So per second, they can, many user can able to access that Google. For example, take your university result website. For example, you can take your Anna University result website itself. So while they told your result have been published, and if you go to the particular website, and if you are going and seeing the result, only few students will get the result, few students will not get. Okay, server is busy, you will get. Okay, keep on going on loading. Yes, so what is the issues in that particular website? Now the server will be a dummy. Okay, that is the Anna University website server the result website server, the server will be very small and it will be dummy. So the number of user limit for per second will be very limited. For example, let it be 1000. Okay, so for the accessing of that particular website, university result website, the number of limited user will be they have been kept only 1000. So when you move to the next person of 1001, the 1001 people will not get the result. Only the certain 1 to 1000 students will get the result, and the remaining students the server will be busy. So once the 1000 students have been published, have been shown to the particular user, then the remaining set of the pool will be get loaded in the website, that is your university result website. So this is the issue we are facing in your university website, result website. So the good example for shared memory itself, Google. So the Google server is very large, so you can able to able to get your information, that is your information from the Google website, that is Google server. The server going to act as a memory now. So many user, that compute I told you, 3 computer. Now number of users will be a computer now. So the number of users going to access your Google, Google will be my shared memory. So going to share your information to the multiple number of users, so that you can use by your concept which is called as parallel processing challenges. So under this shared process, there is a one more concept which is called as so while you move to my shared process now, there will be a term which is arrive, which is called as thread. THREAD. So there is a concept which is called as thread. What is meant by this thread? So this will called as lightweighted process. So where you are going to use this thread process. So thread process you can use in your mobile, in your laptop also we have this thread process. For example, your automatic dictionary is on in your mobile phone. Okay. So when your automatic dictionary is on now, if you're typing your message, okay, and you're sending a message to your friend. So while you're typing, if there is a spelling mistake now, it will be shown by underlining of red or blue color line, no, and that is called as thread. Threads now, you're just there is a spelling mistakes, which is you are having sending a information which is very wrong. So you have to replace those things. So to replace those things, what you have to do? The certain thing, that certain element word should be stored in your certain set of pool. So that pool will called as thread pool. So inside this thread pool, we are going to show all the datas, all the words, okay, all the words which is you are going to use, that all will be stored inside this thread pool. So while you are typing a word as paper, if this paper word is inside this pool now, it will not show, there is no spelling mistake. If the particular paper word is not stored in this pool now, it will show as there is a spelling mistake. So you have to replace things. Okay, so that is the thread pool. The information which is available in the particular server, when you are searching by the user, it is available there now, it will give the result. If it is not there now, it will give there is a error. So that is called as thread pool. So while you are going for shared memory, this is the one parameter will come under this thread pool. So this shared memory and thread, all these things we are studying the topic which is called as hardware multi-threading, followed by your shared memory. So while we are studying there, we can study what are the different type of architectures and what are the different type of types we have, we can see in that. So now you know what is the parallel process challenges. Our challenges is speed. So now while doing this parallel process challenges, by using, why we can't be able to use your multi-process now, this is the 5 reason we can't be able to use the multi-processor program simultaneously. The first one, scheduling. What here scheduling going to tell you now? Scheduling now, you told you have 8 reporters. So while after 8 reporters, you have to give a schedule for that. That is what will be my process time, what will be the bandwidth. That is schedule now. For example, reporter, I told you 8 reporter now, I'll give only 8 page. Within that 8 page, you have to complete. Okay. And you have to give a hint. Okay, so this you're going to give a overview. What is the issue? What will be the objectives? What will be the abstract? And what will be the advantage and disadvantage of that particular issues? You have to, those things should be mentioned in your particular report. So that will be your scheduling. The same scheduling when you're compared to computer. What will be my process time? What will be the communication bandwidth, frequency? All these things you have to tell to all the particular 8 tasks. After telling all, after done your scheduling, your second thing, you have to divide your work. You have to divide your work into parallelly, into small. So you have to participate your work into the small parallel pieces. So you are dividing the work. Once you divided work, that work should be given equally to all the workers, to all your reporters. So schedule பண்ணிட்டீங்க. After scheduling, you have divided the large program into small program. So once you divided that small program, after dividing and kept your small pieces, no, that pieces should be split equally to all the workers. For example, for work for reporter 2, reporter number reporter 2, you should not give two types set of report to write. If it is you are giving one to all the reporter, that reporter 2 also should give only one reporter should be handled by the particular reporter. So if you are equally splitting only one to each, now one. If you are splitting each one to carry two report, now each reporter should have only two reports. So this is you have to balance your load. The fourth one will be your time to synchronize. Time to synchronize will be a very important challenges in your parallel processing. So a synchronization will be a very important challenges in your parallel processing, because all your processor, okay, all your processor have a equal work. Okay, so all your process have a equal work. So equal work na equal load. So it must complete the particular task in a particular specific time. Okay, why the synchronization is very important for parallel processing is because all the process should have a equal work and should complete the work within the particular specific time. So for parallel processing program, this time synchronization process is a very important factor for that, because if a particular process or a task it is not completed in the particular duration of time, then your parallel processing will not be get uptime. Okay, so what happens if this particular processor or task is not completed within the particular time limit, now your parallel processing will not be achieved. So always the time synchronization between your reporters should be maintained. The last factor is overhead of communication between the parties. Parties now will call here as, will let it be your reporters. So you don't know that the reporter one don't know what is the work given to your reporter two, or a reporter don't know what is the work is given for reminder reporter. So you have to know what is the information should be given for each reporter. You have to design the particular coding for that. So to know knowing which task must be communicated with your each others, with each reporters, it will be critical during the design stage of the parallel code. So this is all the things you have to keep in your mind for your parallel processing challenges.